Hello everyone, good evening. I hope I'm pretty much audible as well as visible. Audible as well. Hello Shubham, thank you for joining here. Apologies, I got slight delay today. I'm just wrapping up some work. Cool. So today we will be talking about how we are going to infer some results and what is the meaning of inference first of all, right? So what exactly we do when I say inferencing, right? So what are those important things prominently? We will be talking about that. Right? So that's basically what the agenda of today. Let me just set up a few things and then we can start. Give me a minute. Exactly we do when I say inference. Cool. So I think we are good to start. But again, I'm pretty much happy to take any questions. So because I do remember, Shubham, you had some question in the last class, right? So if you have done something else, post that, and then if you have something which you want to talk about, so I think we are good. Please let me know so I can take up your question, and then we are good to start. Please let me know. There was a issue at my end, so I got dropped off. I hope I'm pretty much audible as well as visible now. Cool, great. So yeah, thank you so much for confirming. So today, as I was saying, we will be talking about how I'm going to infer some result from my machine learning or data science problem, whatever we have. So I'll be prominently talking about how inferencing a result plays a very important role here. And in fact, even before going into that, it is very important to understand when I say inferencing, what exactly inferencing means. So we will be giving you, I'm trying to give you a clear distinction between what do we mean by inferencing of something or what do we mean by prediction of something. So we have been talking about the prediction term quite often. So we discussed about the ML models, we discussed about the different types of ML models, we were talking about supervised methods, we're talking about unsupervised methods. So each one of them has an objective where we are trying to predict the data for something in future, right? So what we said how the values would be for each of these use cases in future, right? So we have been talking about the data points, like how the things will happen in future. But now here, in terms of prediction, we are prominently looking at my future data with respect to my past history, right? So my prime objective of any AI ML methods or predictive modeling, when I say this, is what I'm trying to predict the future trend depending on my past history. But at the same time, it also becomes very important that whatever model, whatever mechanism I have used for predicting those results in future, how can I leverage it to take some business decisions? I'll give you a very simple example. Suppose I say that I want to predict what will be the sales of my products which I'm selling right now on my e-commerce website in the next month. This question is very simple. I have been analyzing my past trends of my sale value, and then what I'm trying to look at is my sale of the products in future, right? So my objective is to find out the sale value in future, and for this sale value, what I'm trying to find out, like based on the past history, my objective is to see the future value of my prediction. That is very simple. So obviously I'll look at the data set, I'll try to do some analysis on top of that, and then eventually after doing this analysis, I'll be figuring out what will be my future value. And for that, definitely the skills such as time series forecasting, my regression model, whatever suits well here, we will be ultimately fixing that, right? So right now, with this, what we're doing is, with the historical data, we are trying to predict the future, and whatever mechanism I use, I'm least bothered with that. My only objective here is to get the best predictions in the future. But in most scenarios, that might not be needed 100% of the time. Look for an example. Suppose I know that from the model, I'm seeing my future predictions are not looking that great. There might be a scenario where my future predictions are not looking that great. So now from a business perspective, I need to take a decision on which I will say that, okay, now I want there's some network fluctuation, guys, so I'm getting dropped off in between. Please pardon me for that. So what I was saying is, I'm trying to equally find out based on these actions how I can actually take a decision for my business, right? So my end objective here is to find out the reasons, to find out the patterns on which, yes, I can benefit my organization. So with this part, if I have to say, these will be my factors in which now I can say that based on the models which I have prepared, it is giving me a direction that yes, these could be the potential influencing factors for my model to run. That is totally possible. And that is where now I'm saying that this becomes my prime importance. Does that make sense, guys? Right, I think I'm facing some network fluctuations, and based on which I'm unable to see myself online for quite some time. Okay, apologies for that. Yes, so there are obviously now with this we can purely understand there are two broad objectives of the same problem. We are obviously trying to build a model which can give us the perfect results in future, obviously giving us the best model, right? And the second is I'm trying to find out if I have the perfect model in place. On top of that, how to look at some influencing factors which determines the model performance of mine. And that could be the potential driving factors for any business. And that is where we talk about the inferencing of my results coming into picture, right? So that again becomes my one of the very important driving feature for my part here. Yes, welcome again to the third time. Apologies for that. I'm genuinely facing some network issue, which is quite. I have used my. So just a minute, guys. I'm just setting up things here. Yeah. So I think I should be fine. Just quick confirmation on the chat if I'm audible as well as visible. Let me know, guys, if I am 100% audible as well as visible. Might be the quality would be low, but I think I should be visible now. So I've just corrected my details. Apologies for the delay. So let's quickly start, guys. So what I was talking about is prominently towards discussing the inference part. So obviously we will be discussing a bit more detail in this. Now, today we are going to figure out how we can use these details specifically for my introduction of inferencing part. But before that, I'll introduce myself. You know, my name is Arpit Jain. And then the reason why I'm here because data science is what my passion is, and I really like sharing my expertise with people prominently into the data science field for approximately 10 plus years now into multiple different sections. And obviously, I've been talking to students, pretty much a motivational speaker as well. So you can reach out to me whenever you have any general concerns as well. So we can always talk. And it's anyway pretty much a live session. So we will be talking about a lot of other things as well. Okay. So, but again, without wasting time, let's proceed. So as I've said, we will be discussing about the very important part, which is prediction versus the inference difference. This is very important, guys. So we have to understand how exactly we can differ between the prediction and the inference part, right? So there's a slight, very, very minute difference between these two. So generally, whenever we talk about any ML problem, we always talk about the prediction part. We always say that my model is 90% accurate, my model is 85% accurate, so I want to increase this model performance and whatnot. So all the techniques which we have been listening or learning so far is primarily focused around how to improve this model performance, right? So ML techniques, all of this prime objective is improving the model performance by whatever methods we have. So on top of this, when the objective is not primarily to look at the model performance, but also to understand the driving factors for those model performances, we talk about the model inference. We try to infer the model which we have built up and accordingly help the business take some respective decisions. We're going to take a quick descriptors along this area. And in the second part of our discussion, we will be talking about certain feature selection techniques that eventually helps us to further fine tune our inference results from the model. So we're going to be talking about that as well. Okay. So let's start. A quick difference between the inference and the prediction part, guys. Always understand this. So first, when I talk about inference, we are talking about using the model to learn about the data generation process. So we are primarily focused towards understanding the key driving factors. Simple industry level examples, if I have to give you, suppose I'm predicting for cancers, right? So very, very academically used data, like predicting cancers from patients, right? So classification problem, simple classification problem. So I know that the model, whichever I will be building, I will have to ultimately evaluate it, right? So I will have to, I'm predicting it for any new patients coming up. So I'll have a model evaluation strategy and I'll be saying that I'm 90% confident that, okay, this person has cancer, like yes, 1 or 0, no cancer, right? But now on top of this, we can also draw some inferences, key driving factors for this person whom I am predicting as 90% confident for having the cancer. What are the driving factors? Maybe this person smokes a lot. This person is of bad eating habits. Maybe this person has high heart issues or whatnot. So whatever my XYZ reasons, right? So these all are my factors, or I would say in simple terms, columns or features or variables which are used to build up a model where I'm saying that 90% accuracy is coming up, right? So inference is that mechanism where I'm trying to learn the general process behind the building up of my model which is there. So predictions are going to help us determine like what exactly my model is predicting, how much confident, how much sure I am for that prediction, whether that prediction is for a supervised method, like where we have the label, or whether I have the unsupervised methods. Again, supervised again have further classifications. But inference, on the other hand, is where I'm going to talk about how the model is helping the business to take some relevant decisions. Okay, so that is where we're going to be using inference part in that area. So generally, how exactly we can define this inference part as well? It is not 100% necessary that all the models, all the ML models, whatever we have been knowing here in our mechanism part, will be helping us to give us the right model performances, right model inferences. There are certain methods which are less interpretable. Less interpretable means these are like a black box technique, getting the hidden sense behind the driving factors of any particular model is not that easy. Okay, so definitely there is a difference between models that are suitable for inference and those are not for model interpretability. So we have to make sure that we understand the objective behind our running the model here. So whenever I build up a machine learning model, we have to make sure that what exactly my prime objective is. If I'm looking for a model which is only, I mean, if my objective is to find out the best model performance, like suppose I'm going to build up a model which is going to detect, I am free to choose any model which I can take care of. But the end objective is that I look forward to the best model which can give me the best performance. I'm least concerned whether that model or whether that algorithm, whether that technique is also giving me the interpretation capability or not. So my objective is clear cut. My objective is to build a model which is giving me the best prediction, best confidence, best performance of my model. On the other hand, if I am also looking at the interpretability concept of my model, then I need to use only those set of algorithms which has the capability for the model interpretability as well. We need to infer the model. So I can only choose a set of features, set of algorithms, set of techniques which gives us this feature, and I cannot go with those which has less interpretability features. For example, I can give you those list of names, I mean the names of those algorithms where the interpretability is very high, very good. Like for example, the generalized linear models, like a linear regression model, a logistics regression model. So generalized linear models, like we also term this as the basic models for regression problem. Linear regression is the ideal one. For a classification problem, logistics regression are the ideals one. So these two methods are generally considered as the ones which are the pioneers for the model explainability, right? And obviously on top of that, LDAs, linear discriminant analysis, support vector machines, decision trees, random forest, so all of these are those models where the interpretability are generally very good, right? And then we are talking about the neural networks model and the non-linear SVMs where the interpretability are generally less, right? So I'll cut down this from here. This is incorrect. So random forest are also considered as a good mechanism where I can have the model interpretability as well from this. Okay. So interpretable model and less interpretable model. So we have to always understand how we can figure out the things from this. Okay, just read your chat, Shubham. So I think you got it. There was some model problem, could be fine. So what we're trying to look at the models which can be interpreted and the models which cannot be interpreted. But again, it is very subjective to what my objective is in terms of problem which I'm trying to solve. If my objective is to solve a problem which can only take the model prediction into my account, so I'm only focused towards building a model which is having the highest model performance, I'm free to choose any complex model as well, with where the interpretation of my model is less probable. I'm okay to choose that as well. But if my objective is along with having the model performance, I also need to find out the model interpretation, like I need to find out the driving factors. I need to choose those algorithms which can give us this feature. Okay, so that's where there's always a trade-off. We have to find out and choose the right mechanism likewise. I want to give you certain examples. So on the prediction part, suppose that I want to predict the future ozone levels using my historic data. So I have my ozone layer, which is protecting us from UV rays. I want to predict the future ozone levels using my historic data. Since we believe that there is a linear relationship between the ozone level and the measurements of temperature, solar radiation, and wind, we can fit in several linear models on top of that. And finally, we can select the model for predicting the ozone model. Note that we are not care at all about the Gaussian assumption of the model or any additional information that is needed to bring the model, giving me the minimize the test error. In this case, my objective here from the prediction part is I'm only concerned towards building up a model which can give us the right prediction of my any input layer. And in this case, I'm talking about prediction of my ozone layer. I can talk about prediction of my cancer patients. I can talk about prediction of my loan defaults. I can talk about prediction of my salary. I can talk about prediction of my price of a product, right? So I am free to choose respective mechanisms or the algorithms on top to fit up this model, and obviously the respective independent features for that will be changing. In this case, I know that my ozone layers are prominently dependent on my measurement of my temperatures, solar radiation, wind, and several other features as well. And on top of that, we are free to choose the linear regression models based on which I'm trying to predict my values of the ozone layers in future. And likewise, I can do the prediction, building up the model as well. But on the other hand, when you talk about inference, right? So my objective here is definitely I am finding out the prediction of this, but I'm trying to harness certain information from the full data set so that I not only care about the predictive accuracy, I'm trying to find out some of the features on which this is dependent on. So I'm trying to interpret the role of the features here on the measured ozone level. For example, by considering the confidence bands of the estimates, I'm talking about certain interpretability of my model based on which now I can take some decisions to finding out the right key driving factors to identify, okay, what would be the ones influencing the results so that my model performances are behaving XYZ patterns. So that is where it becomes very important to find out how we can use the inferences on top of this, right? So two things, always remember, predictions as well as inference. Predictions are prominently focused towards giving you the values of any key KPIs in future. And that KPI could be a regressed value, like a continuous number. That KPI can also be a class. Okay, either thing are absolutely fine. So I'm talking about prediction of my cases, supervised methods, where I'm predicting either a class or a number in future. But in inferences, we are talking about the driving factors for those, based on which now I can take some decision. I can probably look forward for lower carbon emissions. I can look forward to optimize the wind temperatures, and there are so many things I can do on top of this, right? So if I do not know the driving factors, I might be focusing on something which is not that important, influential as well. Simple example, again, take it from the e-commerce website. I say that I am not generating the revenue. So very simple business problem, guys. Let's try to understand this. Many times what happens, we work for any organization and we always come across that I'm not able to generate revenues. It happens. So the managers come to your desk and say that, hey man, I'm not able, we are not generating enough revenues for this month. So please tell us what can be done. right? So in this problem statement, my objective is to not look for the better prediction. My objective is to take a decision based on that pattern which we have identified, right? So situations like this demands you for model interpretability, inferencing of your results, right? So then I'll be saying that, okay, maybe the pricing of my product is not that great. We are not competitive enough, depending on my competitors. Maybe we'll say that we are not having sufficient delivery guys for the delivery on the products on the right time. We're having some very bad comments in terms of delivery timelines. We could say that it could be one of the driving factors where the products which we are selling is of substandard quality. Maybe we're getting some wrong feedbacks about the quality of my product, right? So there could be n number of driving factors which might result for a business situation. And here the business situation is I am not able to generate the revenues. So always understand the mindset. Whenever we solve a business problem in data science, we have to always look forward to our objective. And that is where the key difference between the prediction and the statistical inference of my results comes into picture. And both are equally important. Okay. So how the workflows of prediction case comes into picture. So what we do is the first phase is modeling. So in prediction cases, obviously my objective is to maximize the performance, right? So obviously we have a pool of say n different algorithms, right? So obviously from this pool of n different algorithms, we are going to consider several different models and different parameter settings. So there'll be multiple experiments which will be running on top of my different data sets here. So on my data set, I have n different algorithms, and obviously each one of them having hyperparameters. So we will be running all of these different algorithms and different algorithms performing the experiments, and the objective is to maximize my model results. So we'll try to get the best model performance after running all of these several experiments. And then we're going to identify the model with the greatest predictive performance using the validation test sets and selecting the model with the highest performance on the test set. That's where the concept of bias and variance comes into picture. So what we do in the training time, we always split the data into two pieces, train data set and test data set. So we always try to train on this train data set, and then finally we try to test on this test data set. So we have a train model performance and test model performance. So we have two terminologies here. So train performance, and then we have test performance. Scenarios like bias. So bias, what happens is I'm talking about my training performance being high and my test performance being low. That is where we say we have a bias. I'm able to train the data well. At the time of training, my model is running very well and model is able to identify the right patterns, and ultimately my performance of my data on the training set is very good. The moment I'm trying to predict on test the same model, that model goes bad. So I have a lesser accurate model on the testing data set. So definitely the difference between the training and the testing is very high. So in this situation is called as bias problem, and the variance problem is just the reverse of it. So we try to always take a trade-off between the errors or the model performance of my training and the test set. Ideally it should be similar, and based on these parameters from the n different experiments we have performed in the workflow, we try to choose one of these techniques where I have the maximum model performance. And then once we have selected the model, next what we do, again, understand what is my criteria of selection here. My criteria of selection is model performance. So here always we're going to look at model performance as my criteria for selection. And once the model is selected, at the last, we are going to predict on the unseen data. So we're going to apply the model on the new data set, and we are going to obviously see the results for the unseen data. That is how the workflow of prediction use case works. Second is inference. The inference, let's try to understand it. The very first part is modeling again, and the reason about data generation process, and choose the stochastic model that approximates the data generation process the best. The reason to that is, now my objective has changed. I'm talking about the explainability of my model. So my objective here, I'm trying to model the data based which can approximate the entire generation process the best, and at the same time giving me the right explainability of my feature sets. And even in the model validation strategy, we are going to validate the stochastic model using the residual analysis or the goodness of fit tests. So instead of checking the model performance as 90% accurate or 100% accurate and whatnot, I'm going to check how good this model fits into my selection criteria. What is my residuals analysis? So this will be my selection process for model evaluation strategy. So whatever model I've been building up, which actually approximates the data generation process the best, I'm going to validate it based on my residual analysis or the goodness of fit tests. And ultimately, the last step will be not prediction, inference. So last step is not prediction, it is inference. And in this inference, we are going to take to the model which we have built up to understand the generation process, where we're going to look at the key influencing factors. That's pretty much what we are going to look at for the model build-up process. So key influence factors to find out what are my driving factors for this particular business problem. At last, guys, I'll be talking about, again, on this selection methods, how we can again further fine-tune my business methods by giving you these different data sets. So feature selection methods, again, we have certain different mechanism. Just give me a minute. I think it is getting stuck here. I'm going to pull it here. Yeah, cool. So now I'll be talking about the feature selection method, where I'll be saying that, okay, what all different methods are available in terms where I can say that, yes, I have all the set of feature sets, or all the set of features available. On top of this, if I want to apply something to get the best results, what all would be. So in the selection process, feature selection methods, I have three broad categories. First is a filtered based method. Second is a wrapper based method. Third is a embedded based method. Under filtered based method, we have two further subcategories: information gain and correlation coefficient. What are those? Let me quickly explain it. So information gain comes to a picture where I'm going to say that if I have, suppose, 20 features, and if I take out of these one feature as my parent feature or a root node feature, how good I am able to explain the details of other target variable with the respect of this particular feature set. So how my information is gained if this is the root node being taken. So this prominently comes into a picture of tree-based model. So there is a formula behind that. So information gain is nothing but entropy before split minus entropy after split. So if I take any of these factors as my root node for the splitting criteria, how my entropy is changing before and after the split. That's basically how information gain is calculated. And obviously entropy also has a formula, which is nothing but minus P of log P. So what we do is, again, based on all of these statistical methods, my end objective is to find out the significance of each individual feature sets, whatever we have in our data set. Okay. So with this information gain, we try to find out the importance of each feature. Basically, maximum the information gain, that feature is best. Okay, so that is given the first priority on which the splitting will happen. So basically my objective is to find out where I have the maximum information gain, where I'm able to learn the pattern the best. So filtered based method, I'm filtering out other feature sets where I have lesser information gain. So that is how, again, there's a lot of stats involved in top of that. We will be going in detail once we learn all of these respective algorithms one by one. But again, it does help to find out the right set of feature which I can be using for my selection criteria. So information gain could be one of those. Second is, we talk about, I'm going to erase the ink from here, guys. Just a minute. Yeah. So the next, what we talk about is correlation coefficient. So we always talk about finding the relationship between multiple different variables. So correlation is that index which ranges from -1 to +1, and we try to find out how exactly two different features are interacting with each other. So values closer to my boundaries, -1 and +1, shows maximum correlation. That means it is highly dependent. For example, simple layman term example, age and salary. So I know that as long as my age increases, my salary is bound to increase. Right? There is a relationship between my age and the salary. So again, so correlation coefficient helps us to identify those indexes where we can easily relate multiple such features. So another feature selection methods where we can easily find out, okay, these are the two methods where I have the stronger correlations. Maybe each one of them is not necessary. We generally, what we do is, once we have the higher correlation coefficients for any of the feature set combinations, instead of taking both of them, we choose one out of these depending on my business requirement as well. Another method, filtered based method. So we filter out one of the features if we find out strong correlations between them. Another strong methods to find out the right feature for my interpretability. Next method is wrapper based methods. So wrapper based methods, we talk about forward selection, we talk about backward selection. So for example, suppose we have 20 features and we have run linear based model. So linear regression model we have run. So in the linear regression model, we have something called as p-value, like the probability value for which is demonstrating that how much variance I'm explaining with this particular feature set, how important that feature is. So in forward selection or a backward selection, what happens? First, I'll talk about the backward selection. So suppose I have 20 features, feature 1, feature 2, likewise feature 20, and each one of them has a p-value. So what we do is, the value whichever has the least or basically the max p-value in the reverse order, which is basically demonstrating that it is least important. So p-value, lesser p-value is actually good for your model. Okay. So suppose if my p-value is very, very, very high, that means that that feature is not that great. Suppose that F15 is having the p-value which is very high, above my selected criteria of 0.05 or 95% of significance. So what we do is, we drop that feature. So basically a backward selection method. So I'm going to eliminate one feature at a time. So keep on eliminating features one by one till the time all the features are equally important for me. That's basically what backward elimination strategy is. Reverse of it is forward selection. So on the other hand, on the same 20 features, same p-value, I can first take the best performance, the lowest p-value, run the model again, then take the second best, run the model again, then take the third best till the time I have everything which is giving us the right p-value for me in the accepted range. So again, wrapper based methods are equally good for my selection process. Both forward selection and backward selection are equally good. We use them. The last set of techniques are RFE and L1. These are slightly advanced embedded methods. So RFE is nothing but recursive feature engineering. So we call this as recursive feature engineering. These are primarily focused for random forest model. So random forest model has a specified technique which specifies in giving you the model interpretation, and that is how it is happening with RFE technique. So we will be going in detail for RFE, how the calculation happens and everything once we get into random forest in detail. But again, always remember, random forest does provide a mechanism in which we can have the feature importances also there as part of my strategy. Second is L1 method. So these are regularized regression techniques. It is nothing but as lasso regression. So where it has certain concept behind that. What it does, it minimizes the effect of a feature which is not that grave importance to my model performance. So what it does, it runs the mechanism likewise. It tries to give the importance as 0. It tries to filter out that feature which is not impacting my model performance. So again, it has that mechanism which can do the feature selection method, again based on some statistical rule in the background, lasso regression, which is going to help us do the feature selection method as well at the time of regression. So guys, these are the broadly 3 methods in which I can do the feature selection, but the end objective here is to have the model inferences with us. So giving the model the right set of features based on which I can interpret the importances of each of the features so that I can help the business take some relevant actions on top of these data pointers. So broadly, guys, this is what I intended to cover today. I'm open to any set of questions, whatever you have. Please let me know so I can take up your questions, or anything in general also. I'm more than happy to take, guys. But this is what I intended to cover today. So I hope that makes sense. So model interpretation along with the prediction of my data sets, both of them plays a very important role. And all of them has their own respective meanings as well, right? So prediction cases primarily focus towards giving the right set of prediction results, the best model. So I'll be more focused towards the performance of my model. At the same time, when I say interpretation, I'm more looking towards the interpretability of my features, right? So that's pretty much what do we look at, guys. Any questions? Cool. With this, guys, thank you so much. If there's nothing, then we can wrap it up. So we can meet again the next day with another set of interesting topic, guys. So wonderful. Lovely talking to you. Lovely talking to everybody. And as always, let's keep on talking. I just got one question from Shubham. Project process. What do you mean by that, project process? Are you looking at how you can start building up a project? Okay. I mean, like, how do you, I get your question. Okay. So in project, the very first thing, I mean, if you have the data, obviously very good, but the first method is data collection. Okay. So generally in academic purpose, we get the data. Okay. So it's a CSV file or an Excel file, whatever. The second is data cleaning. So we do the basic cleaning of the data. Third is data analysis. Then the fourth is model building. And then fifth is model interpretation. And guys, these all 5 methods, techniques are very important for you. I think I have used the just a minute. I think I should not be using it here. I think it is not visible. Okay, I'll just turn off my video feed. So just give me a minute. Okay. Somehow this is okay. Just to put you that. Okay, just to show you, this is what I was showing. So 5 different steps: data collection, data cleaning, data analysis, model building, and model interpretability. So all of these are very important. So whenever you're writing your resume, right? So make sure that you cover all of these 4-5 points in your resume as well. Always helps to make a decent project, the resume, I mean, the good way you can explain things in your resume. Always helps. Does that make sense? Cool. Does that make sense? I have a project idea, not able to discuss where I can, not able to discuss where I can discuss. You can ping me on LinkedIn also. That's completely fine. We can discuss there. Cool. Great. With this, guys, thank you so much. Let's connect offline for this, Shubham. And then for others, see you in the next class. Thank you so much. Bye bye.